In recent years, climate change has accelerated the rates of wildfires across the globe, and British Columbia has not been immune to these effects. In 2023, British Columbia had its worst year on record for wildfires, with millions of hectares of land being burned and tens of thousands of people being evacuated from their homes. Wildfires tend to start in rural areas with lots of forests, shrubbery, and grasslands, and it's especially bad for people living in these areas as they might not have the technology in place in order to detect if a wildfire has started. Wildfires spread quickly in these areas, so it's important to have a system in place in order to alert the community if a wildfire has started to give them as much evacuation time as possible.
As a response to the wildfire situation, our team created EFAST, Emergency Fire Alert System Technology. EFAST was built off the founding idea of quickly, yet effortlessly, alerting people in remote areas such as rural communities, campgrounds, and national parks of a wildfire within their vicinity. EFAST was conceptualized as a vast array of small EFAST units. Each unit consists of a solar panel, fire detector, and siren. If one unit detects a wildfire within its range, the entire EFAST array will turn on into alert mode. Once in alert mode, the siren will blare, allowing people to quickly escape the wildfire.
The EFAST system consists of two parts: a transmitter, which is used to collect the data, and a receiver, which is used to display the data. The receiving end consists of a battery pack, a radio frequency transceiver, and an LCD screen, which is printing real-time temperature and air quality data. The transmitter consists of a radio frequency transceiver, a humidity and temperature sensor, an air quality sensor, a siren, and it's all powered by a LiPo battery that's rechargeable via solar panel.
Now let's see the fire detection system in action. To trigger the fire detection system, a butane lighter is brought close to the air quality sensor. After enough data points are collected, the Arduino sends a signal over to the receiver, which calculates the air quality. After the air quality reaches a certain threshold, the siren is triggered.
This is our siren for our transmitter of the EFAST system, which makes a very loud sound and went through 4 different design iterations to make sure the sound was to perfection. The siren's design consists of 2 main components, the impeller and the casing. When the impeller begins spinning at 3600 RPMs, the siren makes the sound that we all know and love, as that's the optimal wind speed passing through. But when the gap between the impeller and the casing is too large, this sound won't be created, and was the main fault of our 4 design iterations.
EFAST was additionally designed to be generally maintenance-free, with having a solar panel allowing it to act pretty much off the grid, and having a siren, which is generally repairable quite easily and can last for a while.
Our EFAST system prides itself on its modularity and ease of repairability, as to access any of the main components, all you need to do is simply slide open the front door. These main components consist of an air quality and temperature sensor along with a motor and Arduino. The Arduino computes all of the information to the motor and the sensors, while the solar panel powers the entire system. This solar panel is effectively able to provide power to the system for an entire day while sitting under a tree. The receiver was highly based on the design philosophy of our transmitter, that being to be easily repairable and serviceable, with the only exposed components being the LCD screen and the signal processor. When looking on the inside, we can see that the design is powered by 4 different AA batteries. And while this may seem counterintuitive at first, we envision this design to be placed in places of importance, such as fire halls, where the information can be readily accessible, and to warn anyone nearby to evacuate the area immediately, as there may be a fire present.
Now I present the fully assembled EFAST prototype. With the conveniently placed attachment points, an EFAST can be effortlessly nailed or drilled into a tree. In case of required maintenance, the electronics of the EFAST unit are easily accessible through opening the sliding door. Although not implemented in this prototype, many animal-proofing and weatherproofing additions, such as sealing or locking any cracks, will be implemented in future renditions. For a case in which an entire EFAST unit must be decommissioned, the unit can be effortlessly uninstalled and replaced with a simple attachment system.
There are potential advancements the Siren could have, like a network system where it can provide hourly reports of the forest, which can help track early signs of wildfires so that an effective plan can be made to deal with it. To sum up everything, EFAST is a convenient, effective siren with strategic ways of utilizing its design, with the potential to have advanced features with proper funding.
Through the ups and downs and the countless hours sunk into this project, from the bottom of our hearts, we thank you for watching.